I have one more example of I'm thinking of a number type problem, the sort that will be on the test. I'm going to ask you to read through it with me and then try doing the setup on your own in your ISN. Example 3. The digits of a 2-digit number add up to 10. If you reverse the digits and triple the new number, your result is 38 more than your original number. Okay, so we have a 2-digit number. Our number x, y. X being our tens place, y being our ones place. This is not representing an x times y. This is just the number x, y. Okay, so we know, first of all, we know the digits add up to 10. So I get that 10 from right here, from this statement. Okay, so what I know is the first digit, x, plus the second digit, y, equals 10. Then I also know that I'm going to reverse the digits and I'm going to triple what I get, and I'm going to have something that's 38 more than my original number. I want to know what my original number was. So my original number, I need to express my original number algebraically. So if my x is my tens place, my original number is 10x plus 1y. My reversed number is going to be, I'm going to make y my tens place, so 10y plus 1x. Okay. Now, once I've set that up, I'm going to go ahead and reverse the direction of that because it is addition and I can do that. That'll allow me to have my x and my y parts in the same order in all of my equations. And that's just useful for keeping track of things. All right. Now the problem says I am going to triple my new number. So this is my new number, 1x plus 10y, where y is now the tens place and x is now the ones place. So if I triple that, I'm saying 3 times 1x plus 10y. And I'm saying that that is 38 more than my original number. So minus my original number should get me 38. So minus 10x plus 1y is going to equal 38. Now I have a new equation. It's kind of a messy equation, but I can simplify it. I'm going to ask you to pause and go ahead and try and simplify it. I will now assume you have paused and start simplifying it myself. My first thing I got to do is distribute this 3. So I get 3 times 1x, so that's 3x, plus 3 times 10y, which is 30y. And I'm going to be subtracting, and I'm going to distribute the negative there, so minus 10x and minus 1y, and that all equals 38. Now, my next step is to combine like terms. Well, I've got an x term here and an x term here, so 3x minus 10x is going to be negative 7x, and I've got a y term here, 30y, and negative 1y. So 30y minus 1y is 29y. And so that, I have a typo there, that's negative 7x plus 29y equals 38. Okay, I have a simplified equation that I can work with. So I'm going to go back to my original simpler digit sum equation, and I'm going to rearrange it. If I subtract both sides by x, I have y equals 10 minus x. If I subtract y from both sides, I'm left with x equals 10 minus y. Okay, now I've got to decide which variable I'm going to replace. I'm going to replace the x. I could replace either one. It doesn't really matter, but it does matter to me which one's easier to deal with. 29 times something is not as easy as negative 7 times something. So I'm replacing x with what x equals, which is 10 minus y. So I'm going to go in here, replace x with 10 minus y. And now I'm going to simplify. So I've got to distribute negative 7 times 10, which is negative 70. And negative 7 times negative y is going to be positive 7y. And that's going to be plus 29y still equals 38. Okay. Now I'm going to I can either get rid of negative 70 or I can combine like terms. I'll combine like terms. So minus 70 plus, so 7 plus 29y is going to be 36y. It's going to equal 38. Now I'm going to add 70 to both sides to get rid of minus 70. And I'm left with 36y equals, okay, 38 plus 70. Let's work that out. So that's 108. All right, 108 happens to be 3 times 36. 6 times 3 is 18. 6 times 30 is 90. 90 plus 18 is 108. So I'll be dividing both sides by 36 because clouding what y actually is. And so y equals 108 divided by 36, which is 3. Now I can go back into my original equation and I can figure out what x is by replacing y with 3. So x equals 10 minus 3 equals 7. So my x number is 7. My y digit is 3. So my original number is going to be 10 times 7 plus 1 times 3, which is 70, plus 3, which is 73. A lot of that was probably unnecessary, but our number is 73. Okay, so that's the answer. Now, here's the challenge to you at this point. I could keep coming up with these, but really I think you'll do better if you actually start coming up with some of your own. And the challenge I give you is for you to pair up with someone, focus on two-digit numbers. I encourage you to use calculators and paper to make sure that you get your calculations right. But come up with a number and set it up for someone. I'm going to show you how I came up with mine. So for transparency, I came up with the number 73. That was the first thing I did. I came up with my original number. Then I added up the digits. 7 plus 3 equals 10. Okay. Then I figured I needed to come up with an equation where I reverse the digits. So I reverse the digits, I get 37 here. And I figured if I tripled 37, I'd end up with something more than 73, so I could do the subtraction. So I triple 37. 3 times 7 is 21. 3 times 30 is 90, so I get 90 plus 21 is my tripled version. I get 111 is 3 times 37. So I reverse my digits for 73, I got 37. So I'm setting up my scenario. So I then worked out what the difference was. 111 minus 73 equals 38. And then I immediately knew that what the deal was going to be. So I take my original number 73, I reverse the digits, I triple it, and I get the difference between the new tripled reverse digit number and the triple of the reverse digit number and my original number, and I've worked out that the difference of that is 38. So we go back to my problem, and I've said the digits of the number add up to 10. Okay, and we see that 7 plus 3 for 73 is 10. And then if I reverse the digits, so I reverse them, I got 37. And then I tripled 37, I got 111. And then I did 111 minus 73, and I figured out that that was 38. So then I had all the information that I would be giving you in the problem. I'm giving you the sum of the two digits, and I'm giving you the difference between my new number and whatever I've done with it and my original number. which is 38. And then I ask you, what's my original number? So you should try and create one or two of these of your own and test it out. Test it out with each other and see if each other can figure it out. Please try and figure it out using a systems approach. Many of these can certainly be done with guess and check, but I want you to be able to work things out with a systems approach as well.